Hello, and welcome back to another IB Math Speedrun with me, Vince, and in this one we'll go through the sine rule. So what is the sine rule? The sine rule states that if we have a triangle here, ABC, then it states that A over sine A is equal to B over sine B is equal to C over sine C. And so more or less the ratios of the sides to the angle opposite them should all be equal. And so it's used to solve triangle problems with side lengths when we're given two angles and the length of one side, or we're given the length of two sides and an angle not between them. However, there is one ambiguous case of the sine rule, and it is when two triangles can be constructed from given information about two sides and the non-included angle. Say we're only given information about B and this side and this side. Well, we could also equally, if the side wasn't as large, let's make that a bit smaller. B and then A. Well, if we don't know any information, let's erase C. We don't know that, we don't know this. Well, we could also construct this kind of triangle, which would also fit the parameters of having this angle in these two sides. So this is the ambiguous case, and so normally there might be two values actually of the correct answer, and so that's why it might cause problems. But let's jump into some questions about this. Hello, sorry I'm back, so we'll do every other question this time. So first we need to find the unknown angles and sides of this triangle. And we have 45 degrees, we have 40 degrees, and 7 centimeters. So, if we know this is 45, this is 40, this angle must be 180 minus 45 minus 40, which is equal to 95 degrees. Okay, so now we can use the sine rule. So we have A over sine A, which is 45 over sine, 7 over sine 45. So 7 is the ratio between all of these. So 7 is equal to this side over here. Let's label this R, P, and Q. So 7 is equal to P over sine 40 is equal to Q over sine 95. So 7 times sine 40 is equal to 4. So P is going to be equal to 4.5 effectively. And then 7 times sine 95 is equal to around, it's almost 7 as well. Is that correct? Yeah? I'm getting around 6.97 for that side. So let's just check if that is correct. Hold on, made a little bit of a mistake. 7 over sine 45 is equal to 4.5 over sine 40. So 7 times sine 40, am I working in degrees? It's equal to 4.49. So we have 7, sine 45 is not 1. Oh, I'm being silly. Oh dear. So yeah, this should be 7 over sine 45. I was thinking in tangents. Anyways, 7 times sine 40 over sine 45 is equal to around 6.36. And then 7 over sine 45 times sine 95 is equal to around 9.86. So yeah, these look like more believable numbers. So let's move on to the next question. Next question is a plane flying from P to Q followed a course from P that had a 15-degree error. After traveling for 80 kilometers, the pilot corrected the course by changing direction at a point R and flew further 150 kilometers to reach Q. Assuming the plane flew at a constant 400 kilometers per hour, how much time was lost due to the error, to the nearest second? Okay, so, and then we have a diagram, a very helpful diagram here. So, we have P, Q, R, we know this is 15 degrees, and we know this is 80 kilometers, and we know this is 150 kilometers. So we need to find the difference between this distance, this line over here, and these two lines over here. So we can do that using Sine Rule. So what we have is we have 80, 150, and then so we have 150 over sine 15 is equal to 80 over sine Q. So we have sine Q is equal to 150 over 80 divided by sine 15. Sine 15 is 1 over sine Q. So we divide by sine 15 and then we have 1 over this. So we got sine Q is equal to around 0.138, and so Q is approximately 7.93. So we get that this is approximately equal to 7.93. And so finally, if we add up those two angles, we get 180 minus 15 minus 7.93, and this angle should be 157 degrees. And so we can get the final side by applying the same thing. So we get 150 over sine 15 is equal to x over sine 157. So from this we get 150 times sine 157 divided by sine 15 should be the length of that side. So I'm getting that's equal to 225.8. So this is 80, 150, and then 225.8. So now let's get the difference in the distance between these two. So 225 minus 150 minus 80. And we're getting that this longer path was around 4.16 kilometers longer. So if the plane flew at 400 kilometers an hour, it would take this over 400 hours to cover that distance. So that's around 0.0104 hours, which we multiply by 60, so we get that it was around 0.624 of a minute. And so multiply a minute by 60 seconds in a minute, and we get that this caused around 37 seconds of a loss in time, except the book says 41, and it might potentially be due to a rounding error somewhere, so I'm going to discount that as a rounding error. Yeah. So, finally, on to the last question. When we have the diagram below shows 3 points A, B, C on level ground. A vertical mast MA stands at A. The top of the mast is supported by wires on the ground. Two such wires are fastened at B and C with MBA equal to 64 degrees and MCA equal to 23 degrees. Given that both B and C are 15 meters apart, find the length of both wires and the height of the mast. Okay, so let's just draw a diagram out. It looks something like this. So over here we have A, M, B. This is 64. And then we have an extension to C, which is 23 degrees. And these are both 15 meters apart. Oh, but we know this is 90 degrees actually. So we can simply calculate that as 90, this is 64. So the other one must be 90 minus 64 degrees, and otherwise this is 26 degrees. And similarly, 90 minus 23, so this must be 67 degrees. So this total thing is 67, and the small one is 26. So now we can calculate the difference and therefore the height. So we have this MA side, so MA over sine 64 is equal to, let's call this x, and so we have x over sine 26. So we can, but we actually have another equation we can get, and we have MA over sine 23 is equal to x plus 15 over sine 67. So let's look at this. Let's rearrange this to get both in terms of MA. So we have sine 26 over sine 64 is equal to 0.48. So 0.488 MA is equal to x. And here we have sine 67 divided by sine 23 is equal to 2.35. 2.36 actually, MA is equal to x plus 15. So if we substitute x in as 0.488 MA, what we get is this minus 0.488. So around 1.868 MA is equal to 15. So we have MA is equal to 15 over what we got as the answer. And so MA is around 8.03 meters tall. Okay. So now we need to calculate MB and MC, effectively both the sides, and so we can do that because we know this is sine 90. So we have MB over sine 90, which is 1. So MB is equal to 8 over sine 64. So that's equal to that over sine 64. I'll put them in the exact values. So that's around 8.93, and then MC is equal to 8.03 over sine 23, which is equal to divided by sine 23. This is equal to around 20.6 meters. So yeah, that should be correct. So that was all for this speedrun. I hope you enjoyed, and I hope to see you in the next one.